So, in the previous class, we had started discussing about periodic motion. Okay, so we had given the definition of time period, we have given the definition of frequency, we solved a numerical related to heartbeat when we said, okay, pulse rate is this much, pulse rate is 75, then how many times the heart is beating, what is the frequency of heart, pulse rate is nothing but number of beats per minute. So per second, how many times it is beating, that is its frequency. Inverse of frequency is equal to time period. So we solved one numerical on this. So in oscillations, today we'll study about simple harmonic motion. Okay. So we'll be studying about simple harmonic motion, which is otherwise called SHM or simple harmonic harmonic motion. So we'll study about simple harmonic motion today. Okay. So there are two types of displacement we'll consider here. Okay. One is linear displacement. Okay. This X is linear displacement. Okay. Another is theta. Theta is angular displacement. So corresponding to every linear, there is some angular also is there. You might have when you have studied about your centrifugal force and other things, circular motion. Okay, there can be a linear motion, there can be a circular motion. In linear motion, the displacement variable is x, whereas in circular motion, the displacement variable is theta. Okay. Similarly, the in linear motion, the velocity is v. Okay. Similarly, in circular motion, there is a corresponding velocity. Similarly, in linear motion, there is a linear acceleration A or whatever. So linear acceleration, there is corresponding angular acceleration alpha or whatever. So in here it is x, in linear it is x, in angular it is theta. In angular it is theta. That is displacement. Okay. Similarly, for velocity, for acceleration, for everything there is a corresponding thing in the angular motion also. Okay, so we are giving two examples. One is linear motion, one is angular motion. So this is first one is a spring mass system. Okay, so this is, let us say, this is a mass of m, a block of mass m. Okay, so this mass, what you can see is like this is so it was in this condition. Okay, so let us say initially the center of the mass is this. Okay? Center of the mass is this. Finally, the center of this mass is this. Okay. So and and this particular surface, this contact between this mass and this ground, if you consider it to be a frictionless ideal surface, then only it will become a simple harmonic motion. So what happens, like let us say initially this red marked, initially the block is here, let us say. So now it is being connected to the support by a spring. So you have just moved it in the rightward direction. You have moved it in the rightward direction. So it has uh, moved from here to here. Okay. So this displacement from here to here, this once you move it, it will go to a equilibrium position. Then it will overshoot that equilibrium position. Means it is just disturbing. Okay, so you are just pulling it. After that, if it is frictionless, it will go on oscillating like this. Okay, so it will go on oscillating above this the mid position. It will go on oscillating about this mid position. So the motion will be like this. This is the mid position. It will move like this. It will move like this. So it will go like this. Okay. then it will come back like this. Okay. Then it will overshoot the equilibrium position, it will come back like this. Then again it will come back to this original position. So this will be like first your motion 1, motion 2, motion 3, motion 4. So it will go from, if you consider from the original, you consider from the equilibrium position. You consider the mass of the motion of this block from the equilibrium position, it will, the motion will happen like this. So it's a frictionless surface on which a block moves. Okay. So it is a spring mass system. So how the motion is nothing but your x, nothing but is your displacement. So for let us say I'll talk about it. It will be initially for time period t by 4. It will go from uh, this to this. Then another t by 4 it will come back. Then another t by 4 it will overshoot the original position and come back. Then another t by 4 it will again go back to the original position. So it will be something like t by 4 plus t by 4 plus t by 4 plus t by 4, which is equal to t, which is otherwise called a time period. So after every time period, the motion will repeat itself. Okay. So last time also we have discussed, like time period is something, after completion of time period, the motion will repeat itself. Okay.
Yes.
So this is one example, one such example of spring mass system. Okay. So this we have talked about the linear motion. Okay. Similarly, you can see a pendulum. Okay. So you might have done the time period of pendulum in your physics experiment and all. Okay. So let us say this is the length of the pendulum. This string has the length L. So what you do, you might have done in your experiment. You just take this ball from this position to this position. Okay, you take this ball from this position to this position, and you leave it. You leave it. If you leave it, actually there is no air resistance. So see, in the real nature, there will be frictional resistance between this block and the surface. Similarly, there will be some air resistance. But in ideal case, if you assume that there is no air, complete vacuum, there is no resistance, it will keep on oscillating. Okay, from the equilibrium position, it will keep on oscillating like this.
Mean position to
From mean position, it will keep on oscillating. So it will go like this. It will come back like this. Then it will come back like it will go like this. Then it will come back to 0. Then it will overshoot and it will go. So the motion will be like this. Let's say the motion will be like this. It will be like this. So it will go. Okay, from this thing. Then it will come back. Okay, it will come back. Then it will overshoot this. Okay, like this it will keep on. It will keep on oscillating. This oscillatory motion will go on. Okay, so now how do we write this oscillatory, this motion, this displacement? How do we write that? Okay, so this displacement is a function of t. So it's a function of time. Okay. So a equation a x is equal to a cos omega t is the equation. It will define this type of motion. Either this motion, this x will is defined this for a simple harmonic motion for a spring mass system. The displacement is a function of time. Okay. So it will become simple harmonic if it is a function of a cosine function or sine function is simple harmonic in nature. That I will explain. So x is equal to a cos omega t. Okay. So now how we will prove that after time period t this repeats itself? How we will prove?
That it is periodic.
So a cos omega t. So this term should be equal to this term. So I have added another capital T along with this small t. So if this term is equal to this term, that means after time period t, it repeats itself, right? I am telling one is t plus capital T, another is capital T plus 2t or t plus 3t. That means t plus, this is nothing but t plus t, right? So this is small t plus t plus t plus t, right? So like this, after every time period, it will repeat itself. It will repeat itself. So that's why it is called time period. So in the previous session, we had told time period is something after which the motion repeats itself. So if this term remains same after every time period, then it's a periodic motion. That's why t is the time period. So how much will be this time period t? That I have explained here. Okay. So omega, then you write this small t. You write this small t. Then in place of capital T, you write 2 pi by omega. Just you write 2 pi by omega. So what will happen? This a omega. So when you multiply, when you bring in this omega term inside, this will be omega t plus omega into 2 pi by omega. Right?
Yes.
You are taking inside. So this a cos, this is omega t, and 2 pi by omega into omega, it will become 2 pi. Okay. So a cos omega t plus 2 pi is nothing but a cos omega t, because you know in trigonometry, like cos theta,
Cos A plus B.
cos theta is equal to cos 2 pi plus theta.
Yes.
Even sin theta is also equal to sin 2 pi plus theta, because sin 2 pi plus theta, because what is happening?
It will complete.
It will complete. So let us say this. So let us say this is your different quadrant. So let us say this is your angle theta. Okay. So this, when you add 2 pi to this angle. Okay. So from here I just have added 2 pi to this. 2 pi to this. If I add, it will be again be the same angle, right? So this angle is theta. After 2 pi, if you add, this will become the same angle. Same, it will be the same thing, right? So, so if you add 2 pi to any sine or cos, it will remain the same value. So that is the reason we have add 2 pi here. So we have seen that 2 pi by omega into omega is 2 pi. So x will again become a cos omega t, right? So after a time period t, the x value will remain the same. The displacement value will remain the same after a time period t, which we prove to be 2 pi by omega. So we have proven that time period is 2 pi by omega. This is very important. You should always remember. Time period is 2 pi by omega. And this omega is called angular frequency. We'll discuss about it. Okay. You can take a picture of it. So time period is equal to 2 pi by omega, and omega is your angular frequency. Okay. So it is repeating itself after a time 2 pi by omega. So time capital T, its unit is nothing but second. Okay. So the distance, and this we have given the example of linear motion of a spring mass system. So how the block moves, that's uh, the the with respect to time, how the block moves. That is a simple harmonic motion. Okay. Clear? So we have talked about linear motion and we have given an example of a angular motion. We'll talk more about pendulum and schemas system in the coming sessions. Okay. So very important, time period is the duration after which the motion repeats itself. Okay. So a cos omega t or a cos omega small t plus 2 pi by omega a cos omega a cos omega t. So if you take out omega, so t plus 2 pi by t. Okay. So 2 pi by 2 pi by omega. So 2 pi by omega is your time period. That is very important. Time period is equal to 2 pi by omega. Omega is nothing but your angular frequency. Okay. So there is one example how we will say that. Okay, like we have told that okay, x is equal to a cos omega t. It's a simple harmonic motion. So there is one example where they are asking, okay, if this is simple harmonic motion, whether x is equal to sine omega t plus cos omega t is also a simple harmonic motion. The question is, like we know x equal to cos omega t is simple harmonic, very clear. So the question is whether x is equal to sine x is equal to uh, okay. So sine omega t is a simple harmonic motion. So a into let us say sine omega t plus cos omega t, whether it is simple harmonic or not, that we have to see. Okay. So how we prove it? Okay. Let us say what we'll do it here. Let us say a will multiply a root 2 here. Okay. Let me multiply a root 2 here. Then inside, if I am multiplying the root 2 outside, I'll have to divide, I have, I multiply root 2, divide root 2, it remains same. Okay. So this becomes sin omega t plus cos omega t. Okay. So let me take root 2a, okay, root 2a, and this 1 by root 2, let me take inside. Sin omega t into 1 by root 2 plus 1 by root 2 into cos omega t. Right? This equation becomes like this. So this becomes root 2a. Then what? You know in trigonometry, cos pi by 4 is equal to 1 by root 2. Right? You know cos 45 degree. Pi by 4 is nothing but 45 degree, right? Yes. Is nothing but your 1 by root 2. Similarly, sin 45 is also equal to 1 by root 2. That is there. So you remember like this 30 degree, 45 degree, 60 degree, 0 degree and 90 degree. These 5 angles are very, very important. You should always remember the value of this. Okay, so sine, if I say in terms of sine, sine 0 is 0. Okay, sine 30 is half, sine 45 is 1 by root 2, sine 60 is equal to root 3 by 2. Sin 90 is equal to 1. So this you should always remember. At least one quadrant, you should always remember the value. Because in other quadrant it will be somehow it will be the similar values you will get. So at least one quadrant of value you should always remember. So this is for sine. Okay, this is for sine, you should always remember. Similarly for cos. Okay. Cos, what is cos? Cos 0 is equal to 1. Cos 30 is root 3 by 2. Just you remember that this will come here. Then cos 45, it will remain the same, 1 by root 2. Then cos 60 is half. Then cos 90 is equal to 0. Okay. So what happens in sine? The cos 0 to 90 will become like this. Okay. Whereas in cos, this curve will at 0 it is 1. So it will just the inversion of it. This is sine, this is sine, this is cos. Okay, this is like if you consider this as omega t or theta in the x-axis, in the y-axis it is your displacement. So after let us say this is 0 and this is 90 degree. Okay. So no, sorry. Uh, this
Not
is not
90
90, this is pi by 2. Sorry, pi. 180 degree. So up to 90 degree, up to this is pi by 2. Okay. So the sine will reach the maximum when it reaches pi by 2. That's what it will reach the maximum when it reaches pi by 2. The cos will be minimum when it reaches pi by 2. That you can see. Right? So, um, this you have simplified like this. So this you can write as root 2a. Then in place of sine omega, in place of 1 by root 2, you multiply it by as cos pi by 4. Right? Cos pi by 4. Then 1 by root 2 is sine pi by 4. This is just some manipulation or adjustment, not adjustment. Like to arrive at a particular formula, you are writing one as cos, another as sine into cos omega t. So this is your equation. So in trigonometry, you have studied sine a plus b is nothing but your sine a into cos b. You remember or not?
Yes.
So cos a into sine b. Right? This is the formula for sine a plus b. Similarly, sine a minus b, we are not applying here, but you should remember always. Sine a into cos b minus cos a into sine b. These are the things, see, we say we should not memorize anything, but these are the things you should always remember. Otherwise, you don't have the time to derive in the exam. So, there are certain things we should always remember, like sine square theta plus cos square theta is equal to 1. These are the things you should always remember, like say tan square theta plus 1 is equal to sec square theta. Okay. Similarly, cot square theta plus 1 is equal to cosec square theta. So these are all nothing difficult to derive because uh, uh, how we derive, like say sec square theta. Sec square theta is equal to 1 plus tan square theta. How we derive it? Because 1 tan square theta is nothing but sine square theta by cos square theta. Okay, right?
Yes.
So this becomes cos square theta plus sine square theta, cos square theta plus sine square theta, sine square theta divided by cos square theta. So sine square theta plus cos square theta is 1, so 1 by cos square theta is equal to sec. 1 by cos is sec, that you know, right? So these are, if you remember the basic one, sine and cos, tan, cot, cosec, sec, everything will follow. They are all interlinked. So you know here sine theta cos theta, then sine by cos is equal to tan. So if you derive 1 by 2 by root 3 by 2, you will get tan 30. Similarly, cos by sine is equal to cot. So, so you know tan 45 is equal to 1 because you are dividing 1 by root 2 by 1 by root 2. So these are the things. Okay. So now you have written this equation x as root 2 into a. Then you know it is sine a plus b. That means you can write it as sine omega t plus pi by 4. Right? Right? So this equation x becomes root 2a sine omega t plus pi by 4. So, this is something similar to this. Because it is a sine function, it is a cosine function, it is a sine function. So whether it is cosine function or sine function, we can see like this is a sine function, this is a cosine function. So if it will behave like this, it will be behaving like this. So similarly, it will behave like this curve. So one curve will be like this. Sorry, it will come like this. So another curve will be uh, so one curve is like this. Another curve will be uh, sorry, it will be not like this. Actually, it will be like this. It will be like this. It will go to the negative side. I am sorry. It will be going to the negative side. If you write the value, you can know it actually. Okay.
Okay.
So if one curve is like sine curve is like this, the cosine curve will be like this. The cosine curve will be like this. Right? Sorry, it will start from one. Okay, so it will be starting. It will be yeah. It will be like this. It will draw it again. If this is your sine curve, this is your sine curve, your cosine curve. Like this. Okay. So whether it is sine, so whether not necessary that it should be in terms of cos only. If it is sine also, it's a periodic motion or simple harmonic motion. So we have proven that this equation, that was the question, a sine omega x is equal to a sine omega t plus cos omega t. It can be simplified in terms of only sine, and it becomes a simple harmonic motion. So that was the question. So we have simplified, we have readjusted it, the sine and cos into one sine function. So your displacement becomes a function of sine. Sine. So sine function is simple harmonic in nature. Okay. So that is one. Okay. Uh, what is written here? E. Third one.
E power minus omega t.
Okay. E to a minus omega. So you take a picture of this. Take a picture. So the other questions are whether the which of the following function of time. So these are all function of time. X is a function of t. So which of the following function of time represent periodic motion? So we have proven that a sin omega t plus cos omega t is a function of time and it is a periodic motion. Okay. So now we'll move on.
No.
So this is a sin omega t plus cos omega t. We have proven it to be a sinusoidal function. A sinusoidal function or a cosine function, those are all periodic in nature. Okay, that we have proven. Now he is asking whether it's x is equal to e to the power minus omega t. Whether this is periodic in nature? The answer is no. It's a function. It's a exponential function. Exponential function. So the exponential stuffs like let us say this is not periodic in nature. Similarly, the fourth one, x is equal to let us say log omega t. logarithmic power. This is also not periodic in nature. Okay, logarithmic power is something different. Okay, that is also not periodic in nature. So, like the curves will be something. So, logarithmic power, I am not able to remember exactly. So,
Exponentially increasing.
uh, it is, yeah. So, in functions you have solution. So, this is time t. This is log function, log of t or whatever. So, this will look like this. So, it's not a uh, uh, not a simple harmonic motion. Similarly, x is equal to e to the power minus omega t. It is nothing but 1 by e to the power omega t. Okay. So if you keep on increasing the time, this term will go on increasing and the function will keep on decreasing. So this is log. Similarly, the exponential function e to the power minus omega t, maybe it will be a form like this. It will exponential decrease. That's why we call exponential decrease. Okay. So e to the power omega t, it can be exponential increase. Okay. So when we say that linear increase, uh, so if something is increasing linearly, the rate of increment is not high. Okay. But if it is something, when we tell that when we transfer knowledge, the knowledge increases exponentially. Why? Because one person is teaching, let us say 2%. 2% will teach 4%. 4 will teach, let us say 8. Like that, it will go on. Okay. So there will be exponential increase. Okay. That means the rate of increase is very high in case of exponential. Okay. The rate of increase is very high in case of exponential as compared to linear. Okay. So in linear increase, you say y is equal to mx plus c, right? That means equation of a straight line. So depending on the slope, it can be like this, it can be like this, or it can be like this. It all depends on the slope, the same. Okay. Yes. So if, let us say this slope is equal to 45 degrees. So for every x and y will be equal if it is 45 degree. So if it is 45 degree. But if the slope is less than 45 degree, for a given x, y will be less than x. If the x is more than 45 degree, for a given increment x, the delta y will be more than delta x. So for for slope m is equal to 45, your delta x will become equal to delta y, right? For slope, like slope is nothing but your theta, let us say theta is theta, okay. Slope is nothing but your tan theta, okay. So theta greater than 45, theta less than 45. If it is greater than 45, your del y will be greater than delta x. In the x-axis, you have delta x. So if the slope is less than 45, your delta y will be less than delta x. Clear? So, so when we say that slope is 90 degree, what does that mean? That means it's a completely vertical line. When it is completely vertical line without, like suppose it is 89.9 degree. It is for very little increment in x, the increment in y will be huge. So you show it like this. So what is slope actually? It is like this. So for this line, for a line like this, for a line with high slope, okay, what will happen? For the same increment, let us say this is delta x, okay. So for this line also, if I put the same increment like this much, you can see how much is the delta y. So here delta y is, let us say it is for 45 degree, for 1 it will be 1, but for that slope nearly equal to 80 degree, for 1 it can become equal to 10. So what is slope? It is nothing but y by x, nothing but 10 by 1. That is the slope. But when it is 1 by 1, it will become 1 by 1 and it is 45 degree. So so when we are going on a steep gradient, that means you are telling the slope is very high. What is the slope? Slope is tangent of that angle. Okay. So when the suppose we are telling, okay, when we are going on a stair, Assuming this stair is very steep or the slope is very high. That means you will feel tired if the slope is very high. That means when the civil engineer designs the sting, so he will have for one x, what is the y? For this x, what is the y? For this x, what is the y? So depending on the space constant, he will design. If you have very little space, he has no other option but to give more slope. But if it is a spacious house, he can give like for x, the y can be little less, so that you will get less tired. Okay, that is about slope. Okay, so so the question is whether an exponential function is periodic in nature. The answer is no. Okay, okay, clear. Similarly, a logarithmic curve. Okay, whether it is periodic in nature, the answer is no. So this is the equation for x is equal to log t. This is the equation for x is equal to e to the power minus omega t or whatever, log omega t or whatever. So these are not periodic in nature, whereas the sine curve, it keeps repeating itself. That's why, like after every 2 pi angle, it will keep repeating itself. That's why it is, and so this is x equal to a sine omega t. So this is periodic in nature. Similarly, cos at a zero angle, it will be maximum, so it will be like this. So cos starts with 1 at zero value, whereas sines are start with 0 at so these are the equation of uh, different examples which can be periodic, which cannot be periodic and all. Okay, so we'll further get into the some sinusoidal wave, cosine wave, what is phase angle, and uh, uh, we'll solve some numerical related to this in the next class. Okay, thank you. Yeah, you can take a picture.